Hello everyone. Now let us start with the problems on hydrograph. So we have already seen the dealt with this concept of a hydrograph. So hydrograph is nothing but it is a discharge against the time. Here's a problem wherein you're supposed to find out. You're supposed to derive the unit hydrograph. Okay, so following are the ordinates of a storm hydrograph of a river draining a catchment area of 423 kilometer square due to a 6-hour storm. So derive the ordinates of 6-hour unit hydrograph and plot the same. Okay, so they've given you the table wherein it is a time versus stream flow in meter per second, and time is in hour. And so the first row indicates the time. Okay, it is again continued up to, it starts from -6 to 1 or 2 hours, and stream flow it is in meter cube per second. Okay, so now first thing is you have to again plot this, that is first find out time. So in the given problem they asked you to find unit hydrograph, that is 6 hours unit hydrograph. So time is 6 hours, and area is in kilometer square, that is 423 kilometer square. All right, so now let us assume uniformly varying base flow. Now, base flow is nothing but you have to choose a ordinate from this. Okay, from this 19 points, you need to choose a ordinate where it has a less stream flow. So you can see here it starts, the least of all of these is 10. Okay, 10 to a maximum of 115.5. So base flow is nothing but you have to take the least of this. So the least here is 10. So we'll fix this base flow from 10 to 12 qmax. Qmax is nothing but cubic meter per second. Okay. um okay, so let us see what is runoff. Okay, so you can see here the difference between stream flow and a base flow. So in this diagram, you can see stream flow is the flow which the runoff flows in the stream. That is, it forms through it flows into the rivers, lakes, or ponds. Okay, to the open stream flow like this. And base flow is nothing but whatever flows within this land, that is within the soil, that is called as a base flow. Okay, so now this is a stream flow out of which we are going to deduct this base flow. Okay, base flow is nothing but which flows to this base, lower base. Okay, all right, so in the given problem, so we are taking a stream flow which has a very least number. So the least number here is 10 qmax, and the range is from 10 to 12. So it is like 10 to 12 qmax. So what we'll do is we'll discard the first and the last point. So we'll take only the first point because the first point is in -6 hours. So we'll discard it. We'll start from this first point, and this 0 point, and again the last will give us, see the last ordinate is same, so we'll neglect this. So effectively we'll be considering only from 0 to 96 hours. Okay, and so from this from 0 to 96 hours there are 17 values, and so that the number of steps equal to 17 minus 1. So 17 values are there from 0 to 96. We'll take only 16 values, that is 17 minus 16. Okay, 17 minus 1, that's 16. Okay, now we'll be checking the increase in the base flow. Okay, so increase in the base flow, we have fixed this 10 to 12 as a range. Okay, so this is the 10, and the next point is, now the next discharge value is 12. So we have fixed this number. So how much is the increase in the base flow from first point to this point, last point? You can see here 10 is 0, 10 to 12, 10 to 12. Okay, so the first point is 0, so here it is 10, and the last point is 12. So we'll take we'll deduct these two values. So what we'll do, the last is 12, so it is 12 minus the first value, that is for 0. So it is 12 minus 10 divided by 16 points. Okay, so 16 steps. So it is 1, we have to just calculate these. Okay, we have to calculate from these. So it is 16. So 12 minus last value minus the first value divided by total number of steps. Okay, so now the increase in the base flow. So increase in the base flow is 0.125. Okay, simplify this, you'll get 0.125. Okay, now next in the table you have to draw it like this. So first put time in hours, okay, up to the last point, that is 1 or 2. Then the stream flow in meter cube per second, so which is already given here previously. Again put it in the term in the form of column here. For this, now we are going to add the base flow. Now that we know, the base flow will start from the first point, okay, from here. So we'll write this from 0. We have started it from 0 point. So write this stream flow first. Immediately it is 10. 10. This is the least value. For 0, it is 10. Stream flow. Base flow is also 10. Then for this, you have to go on adding the increase in the base flow, which we have already got here. That is 0.125. So it's 10 plus 0.125. Okay, then same again for this value, again plus 0.125, plus 0.125, plus 0.125, and so on up to the last point. Okay, so up to the last point it is 12, and this is 12.125. Okay, after this, you have to find the runoff ordinate. So the runoff ordinate is nothing but, see here, runoff is nothing but stream flow minus base flow. Okay, that is what is whatever flows through the stream, you have to deduct from the stream, you have to deduct the base flow, so you'll get the runoff flow, direct runoff. So the runoff ordinate is 2 minus 3. Okay, so now go on adding here. 10, let's first mark this, there's no value here. Then we'll start from 0. So it is 10 minus 10, 0. 30 minus this value, 87 minus this value. Okay, so go on deducting this. Okay, so from stream flow you have to deduct the base flow. So once you deduct the base flow, then you'll get the direct runoff. Okay, so the direct runoff ordinate is nothing but this. Now when you add, ultimately we need to calculate the runoff. Now when you want to calculate runoff, add all these, that is 0, 19 up to the last term, 36.5, 10, all the values. Add all these values, that is up till this point, that is 96 hours only. Start from 0 up to 96. So you'll get the value, that is 596. So runoff value is in meter cube per second is 596. Okay, next ultimately you need to calculate the 6-hour unit hydrograph. Okay, see this will give us direct values of the runoff, but we are more interested to find out the unit hydrograph. Now to find out the unit hydrograph, here they have made some calculation, that is of runoff and all. So this is little difficult to understand. So I've simplified this and I've made another calculations. So you can see here. Okay, first you have to calculate the runoff. Okay, I've considered the unit as well. So here runoff is equal to, so we know that it is a 6-hour unit hydrograph. So 6 hours, convert hours into minutes and then into seconds. So it is 6 hours, hours convert into minutes, that is 60 minutes, convert again into seconds. So it is 6 into 60 into 60 is 3600 seconds. So we'll be writing in terms of seconds here. All right. Next, into the discharge value. So total, how much is the runoff we have calculated. So I've told you, you have to calculate the you have to add this, so direct runoff values. So if you add this column, fourth column, you'll get a value of 596, the same 596 I have written here. Okay, again, now again this 596 is in meter cube per second. Okay, and then initially, for you all to understand, please write this in terms of units, so that you'll get to know how we'll convert the units into finally the centimeter value. Okay, then now divide this. Okay, so this is time into runoff divided by area. So area is 423, it is kilometer square. So you have to convert that kilometer square into meter square. So because it is meter square, so first convert kilometer to meter. So kilometer to meter is 10 to the power 3. So we've converted into meter. Then, but this is in terms of meter square, so you have to square the value. So it is 10 to the power 3 into, only you have to square this 3, okay, because we want in terms of meter square. Okay, so now the values here 6R is converted to seconds, that's how it's 3600, and area is converted into kilometer square is converted into meter square, so it is 423 into 10 to the power 6. Okay, so finally you have to put it in the formula and calculate. So it is 6 into, okay, this value, that is we are converting into seconds, so you have to convert into seconds, and then, okay, so we've converted the hours into seconds and area into meter square. So it is now 6 into 3600 into 596 divided by 423 into 10 to the power 6. As here, the seconds and seconds will cancel, and meter square will cancel with meter cube. So you're left with only meter here. So when we simplify this, we'll get in terms of meter only. So it is 0.0304 meter. You have to convert this into centimeter. So multiply with the 100. So you'll get 3.04 centimeter. Okay. Now this is the value you have to use to find out the unit hydrograph. Okay. Now see here. So last column. So ordinate of 6R unit hydrograph is given by the fifth column. So whatever is there in this, so fourth column should be divided by 3.04. So that means it is 19.875 divided by 3.04. Similarly, 77.25 divided by 3.04. Similarly, all the values. So all the values in the fourth column should be divided by 3.04. So you can write this 3.04 value here itself. Then you will get the final value. So the last column is nothing but it is the 6R unit hydrograph, which will be in terms of centimeter. Okay, so don't use this calculations here. I have simplified this and I have shown here. Please use this. Okay, only then it is easy to understand. Okay, all right. All right, so the next type of problem. So in the previous problem, you've seen that it is a storm hydrograph, which is converted into unit hydrograph. Okay, so storm hydrograph is checked at every 6 hours. So here what we have done is we have kept the 6-hour constant and we have converted into a unit hydrograph. Okay, so the next problem is given below are the ordinates of a 6-hour unit hydrograph for a catchment. Calculate the ordinates of direct runoff hydrograph due to excess rainfall of 3.5 centimeter occurring in 6 hours. Okay, now there is a during the first 6 hours there is an excess rainfall of 3.5 centimeter. So they've already given you time and the unit ordinate, that is in meter cube per second. So time is in hour and it is in meter cube per second. Okay, so it is at 0, 3, 6. So it is a for every 3 hours. So it is for every 3 hours unit hydrograph. We have to calculate this for 6 hours unit hydrograph now. Okay, so the desired ordinates of a direct runoff ordinate are obtained by multiplying the ordinates of a unit hydrograph by a factor of 3.5 to the unit ordinate. Okay, so the first column is time in hours, and this is the ordinate of a 6-hour unit hydrograph. So it is 6-hour unit hydrograph. So it is 0, 25. The same values are put here. From 0, 25, 50, 125 and so on up to the last value, it is 8 and 0. Okay, now what you are supposed to do is you have to just multiply the 6-hour unit hydrograph with the excess rainfall. The excess rainfall is 3.5 centimeter to the direct runoff. So it is 0, the first value, next 25 into 3.5 is 87.5. 50 into 3.5, 85 into 3.5. So every ordinate in the second column should be multiplied with the excess rainfall, that is 3.5 centimeter. up to this. Okay, so this is nothing but the ordinate of a 3.5 centimeter direct runoff hydrograph. Okay. All right, that's all for today. Thank you.